All right, now we're looking at proofs of theorems involving isosceles triangles. And this is a proof to prove isosceles triangles. So, this one says, let's see here, if we're given that CA is congruent to CB, and if they drop a bisector, that CD, so this line didn't exist before, but they're drawing it in, and it bisects AB. So they're drawing it down to the midpoint of AB. So now these are equal. Okay? So if that's true, now you've created two triangles, right? Because CD has now created this new two triangle scenario, and CD would also be equal to itself. So now you have two triangles that are equal to each other by side, side, side. And by that situation, you can now prove that A is congruent to B by C, P, C, T, C, because congruent parts of congruent triangles are congruent. And this works every single time with an isosceles triangle. Therefore, you know that the opposite side of congruent sides in an isosceles triangle are always congruent. That's how we're able to always prove that. That's why that theorem always works. So we're going to go ahead and write all that in. Look over here, send these to proof. Get my keyboard out. All right. So we've got that CA is congruent to CB, and then CD bisects AB. And so if it's CD bisects AB, we're going to say that that means, therefore, that, let's see, BD is congruent to, let's see, DA, because of that word bisect. Let's see, that would be a segment bisector, because that's what it bisected. It bisected a segment, not an angle. And then our last piece would be that reflexive, that CD is congruent to CD. And then we have our three congruent statements. All of them are segments, so that would be side, side, side. So now we can say triangle, and you can do in any order, but then they have to match up. So I'm going to pick one triangle. Let's see, ADC. Again, you can go any order you want. But now that I've done ADC, if I've done from that outer corner, I need to go from the outer corner to the other one, B, into the middle, D, and then out to C, BDC. And that is side, side, side. Okay. And now I can prove that those angles are congruent by CPCTC. Congruent parts of congruent triangles are congruent because I've proven that those triangles are congruent. And there we go. And that is how that worked out.